Due to the COVID-19 pandemic, the Geological Survey of Western Australia suspended its normal operational and travel programs, including the 2021 field season. This gave the survey an opportunity to pause its data collection programs and to contemplate the masses of data that have been collected over the past 130 years. The objective of the year-long Accelerated Geoscience Program, or AGP for short, was to synthesize and deliver new exploration-ready datasets derived from pre-existing data across all areas of geoscience, in key regions across the state, but in particular in areas with new or emerging mineral potential. In turn, it was hoped that these datasets would open up new ground and help stimulate the exploration industry. It also gave the survey staff an opportunity to learn how to work, look, and interpret our data in new and different novel ways. Geoscientists from across the survey concentrated their efforts on 4 main projects. Publication of existing data into GIS layers, including improving the accessibility to some of our databases. Data integration and analysis, which focused on the southwest and far eastern parts of the Yilgarn Craton. A statewide critical minerals prospectivity study. And a focus on energy systems, including petroleum, geothermal, and carbon capture and storage. From these 4 projects, we hope that the data will provide geological insights into the composition and fertility of the state's bedrock geology, particularly in areas where the rocks are buried by extensive cover. That they would increase our understanding of the state's potential energy resources, and to catalogue the known critical mineral resources of the state, and to better understand the mineral and alteration systems in which they occur. To date, the AGP has delivered close to 100 new interpreted datasets across the 4 projects, consisting of about 1,080 interpreted data layers that comprise original work by the survey and some repurposed or reprocessed data from other organisations. Every dataset has an accompanying abstract that defines how that dataset was created and where it can be accessed. Although a mineral, petroleum and energy systems analysis by the survey was beyond the scope of the program, these individual data layers can now be used by the exploration industry in almost unlimited combinations to conduct those studies themselves. We hope that these datasets and data layers will help explore undercover and challenge existing exploration paradigms. The aim of the first project was to assemble individual data analyses into a series of statewide data layers, or to repurpose existing data at the state level. For example, the images on the right show a series of contoured statewide isotopic maps, which were assembled from individual rock or mineral analyses, the coloured spots shown on the maps, which on their own, as individual analyses, provide only very limited information. In broad terms, these datasets provide insights into the composition and fertility of the state's bedrock geology. They can help interpret the crustal scale architecture of the state, and they provide information on the composition and thickness of the regolith cover. Importantly though, these datasets provide critical information on the nature and composition of the rocks which are buried by extensive regolith cover or thin sedimentary basins. A key outcome of the AGP has been the development of the major crustal boundaries map for the state. These structures have been interpreted from available geophysics, including gravity, magnetics, and deep crustal seismic data, as well as from the many years of geological mapping across the state. These boundaries represent significant faults and suture zones that separate distinct blocks of crust from each other. These structures play a critical role in transporting metal-bearing fluids from the mantle to the upper crust, where they might form significant mineral deposits. Building on this layer, the state isotopic maps, for example the neodymium isotope map shown on the right, indicate areas of the crust where juvenile and potentially metal-rich magmas have been added to the crust, and also highlight the location of some of the more important crustal boundaries. By overlaying the location of known mineral occurrences, in this case gold and copper in the yellow and orange hexagons, we can begin to see a relationship between these deposits and the crustal structures, such as in the eastern goldfields, or with juvenile isotopic anomalies like those in the Q Rift. The excellent network of deep seismic reflection lines across the state have also allowed us to interpret the location and geometry of the crustal boundaries in the 3rd dimension. The relationship between these structures, also help us build up an understanding of the relative geological timing of their formation and the building of the West Australian crust. Within this state-scale wireframe, we've also been able to interpret and build the intervening crustal blocks, as shown here for the Glenberg terrain. In this way, we have produced a new, consistent, and closed volume interpretation of the major containers of Western Australian geology. This will guide future mapping, as well as allowing us to interpret the geology and mineral potential within each relevant container. The 1 to 100,000 regolith regimes map is a compilation of existing regolith and surface geology maps, with new interpretations using radiometric imagery. The maps have been simplified in the data layer in order to display the three main types of regolith regime. Residual, where there is deep weathering of rock to produce saprolite or dewey crust. Erosional, where rocks are at the weathering interface and are being mechanically and chemically eroded. And depositional, where material like sand and colluvium are being actively deposited. Understanding which regolith regime is present is important not only for understanding the regolith and landscape evolution, but for geochemical sampling exploration programs. From this map, our geologists have also derived a statewide 1 to 100,000 scale outcrop map, which shows the distribution of fresh bedrock outcrops across Western Australia. This project has also focused on improving some of the survey's geoscience databases. In particular, we have worked on the Western Australian Mineral Exploration, or WAMEX, Company Geochemistry Database. Our geologists have harmonised data from over 1 million drill hole geochemical records and over 3 million soil geochemical records. The harmonised database is now publicly accessible online. Despite the known limitations of this data, significant value can be extracted, including the spatial overview of known mineralization locations, trends and patterns, as is shown in the map on the right-hand side, which shows the maximum grade of gold in all drill holes across the state. We have also worked on providing accessibility to the online WAMEX A-number exploration reports. Over 260,000 reports have been digitally captured and are now accessible and searchable through an online Elasticsearch. The Yilgarn Craton is one of Western Australia's most prospective regions and contains significant deposits of gold, nickel, lithium, copper, zinc, iron ore, tantalum and aluminium. Recent high-grade gold and nickel discoveries in the Craton's southwest, for example Julimar, and the far east at Gruyere, have shown that these two poorly exposed and geologically not well understood regions are likely to be as prospective as the Craton's interior. Despite not having worked in either of these areas for over a decade, the Geological Survey holds a vast amount of geoscientific data in these regions, relating to the bedrock and regolith geology, with the potential for uncovering significant new mineral deposits. The aim of this project was to accelerate our geological understanding of these two regions by extracting both Geological Survey and company data, finding new and novel ways to integrate those datasets, and by performing new high-quality geochemical and geochronological analysis on samples from our core library. One of the premium products of the AGP is the creation of a new best-of-scale interpretive bedrock geology map for the southwestern part of the Yilgarn Craton. This desktop map was constructed from numerous primary data layers such as various geophysical images, geochemical and isotopic data, and legacy field observations, to name a few. This project also created a wealth of new geochemical data on legacy samples. Over 1,000 new high-quality major trace and rare earth element analyses were obtained on granitic rocks from across the southwestern part of the Yilgarn. The map on the right shows the results of those analyses with the granitic rocks classified into their particular granite types. For example, the green dots show the locations of sonukitoid type rocks. These are commonly associated with gold deposits in the Eastern Goldfields terrain. New zircon geochronology was conducted on rocks from the Julimar deposit, and alongside legacy isotopic analysis, new whole rock and zircon isotopes were conducted in order to construct a more detailed isotopic map for the southwest and for the state. These new integrated datasets have led to a new and more complete understanding of the tectonic evolution of the southwest terrain, including redefining the nature and location of its boundary with the adjacent UME terrain. The poorly exposed Far East Ilgan region is important as it not only has the potential to host a number of large mineral deposits like those discovered at Gruyere, but the vastly underexplored Neoproterozoic to Devonian Officer Basin could host a number of energy deposits, including natural gas or hydrogen. Equally, this basin may have the potential for storing and sequestering greenhouse gases, as well as being a major store for green or blue hydrogen. Geoscientists from across the survey concentrated mostly on trying to unravel the complex geological evolution of the region, as well as understanding the architecture of the younger basins and the resulting regolith and landform evolution. Additional data layers, like the soil and drill hole geochemical data, provide a mechanism for exploring in this deeply covered region. Critical minerals are non-fuel commodities that are deemed essential for manufacturing industries. The Australian Commonwealth Government identifies 24 priority critical minerals that, most importantly, can be used in the manufacturing of technologies to facilitate the transition to a low-carbon economy. For example, the manufacturing of solar panels or batteries for electric cars. Western Australia is well placed to capitalise on this increasing demand for critical minerals. The state is already a significant producer of a number of these minerals, the ones highlighted in the pink colour in the table on the right. These include, but are not limited to, elements like lithium, manganese, the rare earth elements, and zirconium. It also has known but undeveloped resources of a number of other minerals, and those are shown in the yellow colour in the table on the right. These include elements like chromium, hafnium, magnesium, and vanadium. Although Western Australia has no defined resources of the other minerals shown in the table, it is considered prospective for the types of mineral deposits that are likely to contain them. The state's long-term economic benefit from critical minerals will depend on their continued discovery and the development of these additional resources, many of which are likely to be buried beneath an extensive blanket of regolith cover or thin sedimentary basins. The aim of the Critical Minerals Project has been to apply an understanding of the mineral systems concept and mineralized environments in which particular critical minerals occur, for example, those shown in the table on the right. The approach was to define geological features that might indicate fertility of a region for specific critical minerals, and then to extract GIS-based maps showing occurrences of those features from existing databases. The goals were to generate a sufficiently comprehensive data package that would be of use to critical mineral explorers, and to demonstrate the types of information that can be extracted from the Geological Survey databases. More than 250 individual critical mineral fertility indicator maps have been produced. These maps reflect 5 broad categories of information, which are the known mineral occurrences, prospective rock types, indicator minerals, geochemical signals, and climate. An example fertility map, in this case for pegmatites hosting lithium, tin, tantalum, or beryllium, is shown on the right. This map shows the location of pegmatite occurrences extracted from the 130 years of fieldwork undertaken by the survey geologists, mapped against specific indicator minerals and the mapped pegmatite fields. This is shown on a backdrop of the major crustal structures. When the location of known mineral deposits is added, it is obvious that only a small proportion of all known pegmatite occurrences have been properly investigated. The petroleum industry was one of the hardest hit by the COVID-19 pandemic. The goals of the Energy Systems Project were to help stimulate the onshore petroleum exploration and energy industries by assembling mostly pre-existing but disparate datasets into GIS layers. These datasets provide information on essential elements and processes of petroleum systems, including information on the source, seals and reservoirs, burial and maturation, structures and traps, migration pathways, and the stratigraphic and architectural framework of the onshore basins. The example on the right shows the sea base depth-to-basement image overlain by isopachs for the Malabar salt, a major stratigraphic seal across the central and southern part of the Canning Basin. However, the image also shows that only a handful of petroleum wells have been drilled in the location of this major seal, and so very little is known about the energy potential of this part of the basin. These types of data are not only relevant for hydrocarbon exploration, but are critical for our transition to a low-carbon economy. The presence of major stratigraphic and structural seals in these onshore basins provides great potential for the generation of blue and green hydrogen, as well as the capture and storage of carbon. The majority of the AGP layers are available through our online spatial data portals. The statewide data layers and those from the data synthesis projects can be accessed through the GeoView portal. Data layers associated with the AGP can instantly be highlighted by selecting the Accelerated Geoscience Program theme from the theme bar just above the table of contents. Data pertaining to the Critical Minerals project can be accessed through the Mineral Systems Atlas, and data from the Energy Systems project can be accessed through the WAPIMS data portal. All these AGP datasets can be viewed spatially alongside all the other existing datasets that are available through those data portals, thus providing an incredible wealth of data for exploration. The majority of data can also be accessed and downloaded from the survey's Data and Software Center. At the moment, all of the data is currently available in the GDA 94 projection, but the data is progressively being updated and released in the GDA 2020 format. Data from the Southwest, Far East Ilgan and the Critical Mineral projects can be found under the Accelerated Geoscience folder, whereas the statewide datasets, alongside all other statewide datasets that existed before the AGP, can be found in the statewide Spatial Datasets folder. We've also released a series of standalone geological exploration packages. These contain data for the Southwest Ilgan, the Far East Ilgan, and Critical Minerals. These standalone packages facilitate use for all levels of technical competency and software, from prospectors to Tier 1 companies. They are designed to work offline so that they can be used in the field and other remote locations without an internet access. As these datasets were generated under the state's Economic Recovery Program, all of the data, including the 3 Geological Exploration USB packages, are available at no cost. The hard copy USBs can be obtained from the first floor counter in Mineral House and will be distributed at other events attended by Geological Survey staff. With the production of over 1,080 new digital spatial layers, I've only been able to show you a few select highlights from each project. The individual data layers can now be used by the mineral, petroleum and energy industries in almost unlimited combinations in order to find the next generation of deposits that will aid our transition to a low carbon economy. Importantly, it has provided the Geological Survey staff with a new way to work and to look at our geoscience data. With the easing of COVID restrictions across the state, our staff are now transitioning back to a more traditional way of working, including the planning and execution of extensive field mapping campaigns. However, we will continue to focus on producing content and products like those that have come out of the Accelerated Geoscience Program.